Hi friends, welcome to my channel Learn My Courses with Nagamani. Today we are going to learn finding the eigenvalues and eigenvectors for the given matrix. Okay, so this question is asked by one of our friend. So I am explaining here. So if you have any doubt or if you want to know the solution from me, so please comment below. Or if it is the question is lengthy, then you can send through the mail so that I can go through that question and I'll explain you in the coming videos. Okay, so first we'll see the solution for this. So whenever we want to find the eigenvalues, we have to know the one equation. What is that equation? That is characteristic equation. Characteristic is nothing but modulus of a minus lambda into I1, which is equal to 0. Modulus of a minus lambda into I, which is equal to 0. Okay, so we know that A is nothing but this given matrix. We know that let A equal to this matrix. We know A matrix, and I is nothing but identity matrix, that is 1 0 0 0 1 0 0 0 1, and lambda is nothing but characteristic constant. Okay, with the help of this formula, we can find the eigenvalues. Okay, so directly I will write here. We know that, for example, here A matrix is given 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2. This is the A matrix minus lambda into I, which is nothing but we'll get lambda into 1, 0, 0, 0, lambda 0, 0, 0, lambda. Lambda into identity matrix will get this modulus of this, which is equal to 0. Okay, which is equal to 0. That means what we'll get if we expand this, we'll get it like whenever we multiply with the identity matrix, only the diagonal elements will affect. Other than diagonal elements, all are the as it is it will. So if you see here, modulus of 2 minus lambda, and here minus 1 minus 0, which is nothing but minus 1. 1 minus 0 is 1. Minus 1 minus 0, we get minus 1. 2 minus lambda, we get 2 minus lambda. Here minus 1 minus 0, we get minus 1. 1 1 minus 0, we get 1. Minus 1 minus 0, we get minus 1. 2 minus lambda, we get 2 minus lambda, which is equal to 0. This is nothing but a minus lambda I, which is equal to 0. Okay, now I'll write directly here. For your understanding purpose only, I have written here. See here. So whenever in examination, if you want, if it is in competitive exams, you can directly write the steps because it will reduce the time. So it will save your time. So first I am writing a minus lambda, which is nothing but modulus of a is nothing but 2 minus lambda minus 1, 1. Here also minus 1. Here 2 minus lambda. Here minus 1. Here 1 minus 1. Here 2 minus lambda, which is equal to 0. This we got the modulus of A minus lambda I matrix. Now we will explain. Now we will find the determinant of this one. Okay. So here for finding the determinant, first we have to multiply 2 minus lambda into this one. We have to close this row and this column. Then what is the 2 minus lambda into 2 minus lambda minus this one? So we'll get 2 minus lambda into 2 minus lambda. We'll get 2 minus lambda whole square minus, here we'll get minus 1 into minus 1 plus 1. So plus 1. Next one is minus, what is minus 1? So minus 1 into, here we have to close this column and this row. Minus 1 into this one. Minus of 2 minus lambda AD minus BC minus BC. 1 into minus 1 plus minus 1 into minus 1 minus 1. Minus of minus plus 1. Okay. Then plus here 1 into this, we have to close this column and this one. 1 minus 1 into minus 1 plus 1 minus, here we get 2 minus lambda. Okay, which is equal to 0. We like this step is most important, because if we miss single sign here, then complete solution will get wrong. That's why whenever we are solving or we are finding the determinant, we have to be careful with the signs. This plus or minus. You have to be careful. If you want to check, you can recheck once. If you recheck, that will take only 1 minute. Because of this 1 minute, you can. Okay, it will only take 1 minute. It will save lot of time after the solution. If you get some sign wrong, then whole problem will get wrong. That's why please check here whenever you are finding the determinant of 3 by 3 matrix. Okay. Okay. Now I will expand this one. So first one is this one. Now I will expand this one. So minus 2 minus lambda into 2 minus lambda square will be 2 minus lambda whole cube. Okay. And minus 1 into this one. So you get minus 1 into minus 2 minus of minus plus 1 into lambda lambda. This one we got this term. And the next one is here. This one. What will get? Minus of minus plus 1. Okay. Plus 1 into, and what will get? Minus 2 minus of minus plus lambda, here plus 1. What will get? Minus 2 plus 1 is minus 1, here lambda. So lambda minus 1 will get. So I am writing here minus 1 into lambda minus 1 is lambda minus 1. So I am writing here lambda minus 1. We got lambda minus 1. Here what we get? 1 minus 2 minus of minus plus lambda. What is this? Here 1 minus 2 is minus 1 plus lambda. We got minus 1 plus lambda, same. So I am writing here. So what will get? Plus 1 into, here also you got lambda minus 1, which is equal to 0. I hope this step is clear to everyone. If you have any doubt, I just have expanded here, then I have expanded here, and I have written here. This thing, this third term is expanded and I have written here. Okay, now we know that a minus b whole cube. Another a cube. A cube is nothing but 2 cube. 2 to the 4, 4 to the 8. A cube minus b cube lambda cube minus 3ab, 3 to the 6 lambda into a minus b. That is 2 minus lambda. Then we'll see here. If you see here minus 2, here minus 1, minus 3, minus 1, minus 4. We have minus 4. Here plus lambda, plus lambda, plus lambda. We have 3 lambdas. So plus 3 lambda, which is 0. And now we'll expand this one. So what will get? I will write the black marker so that we can clearly we can find. 8 minus 4 is nothing but 4. We have minus lambda cube. Okay, minus 6 into 2. 6 to the 12. Lambda minus of minus plus 6 lambda into lambda. 6 lambda 12. 3 lambda plus 3 lambda. We got this equation. Here I don't have any space, so I'll erase upper one. Then I'll erase this one and I'll write from here. Okay. If you want to take the screenshot, you can take this screenshot of this one. Okay. Next one is now I'm writing same about. Otherwise, we'll expand directly. We'll, what is this? First, we'll write higher power. What is it? Minus lambda cube. Here we got minus lambda cube. Here plus 6 lambda square. 6 lambda square. Then minus 12 lambda plus 3 lambda. What will get? Minus 9 lambda. Here plus 4, which is equal to 0. This equation we got. Now we will find the roots of for this equation. Okay. If we have power 3, then we have to find the roots using this method. Like first we have to, now I am taking the minus common, then what will get? Lambda cube minus 6 lambda square plus 9 lambda minus 4, which is equal to 0. If you want, you can keep minus also. There is no problem. Just I'm multiplying both sides with the minus, or I'm taking the minus in this above. So if you want to find the rules for this, how to you can find by using here lambda cube. Here what is the coefficient? 1. Here and lambda square coefficient is minus 6. Same lambda coefficient is 9 and lambda power is 0. That coefficient is minus 4. So whenever we have power 3, we have to using this method for finding the roots of this equation. We have to find the solution, like mostly the solution will be lambda equal to 1 or minus 1. If it is not there, then we have to go through minus 2 or 2. Okay, now we'll solve using 1. Okay, we'll take root 1. So here 0, we have to keep 1 we have. So 1 into 1, we'll get 1. Minus 6 plus 1 is minus 5. 1 5s are minus 1 into minus 5, we'll get minus 5. 9 minus 5 will get plus 4. 1 into 4, 4. So we got 0. That means one of the root is 1. So here we can write that lambda minus 1. So if it goes to the after out, even okay, we can write lambda minus 1, this one, into here. Here we have lambda cube. This next step is lambda square. So lambda square minus 5 into lambda minus 5 lambda plus 4, which is equal to 0. So by simplifying this, we will get lambda values. Okay. Now I'll write here. So if you see here, we got lambda minus 1 equal to 0 and this equation equal to 0. Lambda minus 1 equal to 0. This one equal to 0. A into B equal to 0 means A equal to 0 and B equal to 0. Or A into B, which is equal to 0, means A equal to 0 and B equal to 0. So here what will get? Lambda square minus 5 lambda plus 4, which is equal to 0. So from here we will get lambda equal to 1. We got one rule. Next one, this one. Here how we can write 4 into quotient is 1, 4. So what will be the roots? Here we need minus 5. So 4 ones are 4. Like 1 4s are 4, minus 1 minus 4, minus into minus plus 1 4s are 4. So how can we write lambda square minus, here we'll write minus lambda minus 4 lambda plus 4, which is equal to 0. Here minus 5 lambda is split into minus lambda minus 4 lambda. Okay, with here plus 4 I have written as it is, which is equal to 0. From these two, we can take lambda as common. So then we'll get lambda minus 1. Here, from these two, we'll get minus 4 as common. Here, lambda minus, here 4 is there. Here also 4. Okay, we'll get minus 1, which is equal to 0. Okay, I am erasing here, which will create confusion. Okay. And then, if you see here, from this equation, here we have lambda minus 1, lambda minus 1. So lambda minus, if you take the common, then what will have remaining? Lambda here minus 4, which is equal to 0. From this equation, we will get lambda equal to 1, lambda equal to 4, lambda equal to 1, and lambda equal to 4. Here we have lambda equal to 1. So for this matrix, what are the eigenvalues? The eigenvalues are lambda equal to 1, 1, 4. 1, 1, 4 are the eigenvalues for this matrix. In this way, you can find the eigenvalues. If you want, you can take the screenshot of this. Next class, I'll explain you here. Okay. What we got? Eigenvalues. We got lambda equal to 1, 1, 4. These are the eigenvalues for this matrix. Okay.